Hello students, this is Miss Dalton, and this video is over restricting the domain. When you restrict the domain, that means that you're going to restrict the graph to only see the part of the graph within a given domain. So in this graph below, the domain is all real numbers because you can see that on the left side of the graph, right, it goes on forever. And on the right side of the graph, it goes on forever. So if we were to say the domain would be all real numbers. We use this little funny R right here. Okay, but if I want to restrict the domain to only show the part of the graph that's between -2 and 2, what would then be the range of that restricted domain? So let's look at that. If I just look at the part of the graph that's between -2 and 2 on the domain, so domain is x, so if I go to the -2 on my x-axis and I go up to +2 on my x-axis, I'm only looking at the graph that's between these two values. So let's go ahead and highlight that part of the graph. That part of the graph would be from here all the way over to here. So again, we're just looking at this part of the graph that's in pink. Okay, what is now the the range of just that pink area? Okay, the other thing that I want you to keep in mind is look at the ends of the interval. The interval has what I call a hard bracket. So what that means is that this point is included in this section. And this point over here is also included in this section because those are hard brackets. If they were parentheses, then you would have an open circle there. So that's going to play a part in our range too. So if I write the range for just that pink area there, it's going to be the very bottom of the graph, which is at 0. And it's going to go up to the top of just that pink section, which looks to be at 4. Again, there's going to be a hard bracket here because that point at that top of the pink section is included. Another way to write the range is with inequality notation. And so what that would look like is, again, you're going to start with your lowest number, which is 0. Always do less than, and then range is y values. So you'll put the y there, and then less than 4. Okay, then you've got to decide, do I need a less than or equal to? Well, because 0 and 4 are both included, then they have to have an equal to. So this is an interval notation and inequality notation. All right, so let's look at example 1. It says the domain of the given graph is -2 to 5. What would the range be if we restricted the domain to just 0 to 3? Okay, so let's go ahead and let's highlight in that section. So 0 to 3 would be from here all the way over to 3. So now let's again highlight that section. So at 0, it's at the point 1, and 3 is going to be at that y value of 5. Okay, again, because we have the hard brackets, this will be a solid point, and this will be a solid point as well. And so what is that range value? So again, look at the bottom of that section. So the bottom of the green section is at -5. That is going to be a hard bracket. And it's going to go up. The highest section is +1, again with a hard bracket. If we write that in inequality notation, always start with your lowest value, -5. Always do less than. Again, we're doing range, so we'd put a y, less than 1, and then they would both have less than or equal to because those are solid points. Okay, example 2. The domain of the given graph is all real numbers. What would the range be if we restricted the domain to be all the x values that are between -6 and 9 with -6 not included, but 9 included. So at -6, because -6 does not have that equal to symbol, then this is going to be just a soft parenthesis. Okay, at 9, that's going to be a hard bracket, again, because it's got that line under it. So now let's go ahead and highlight that whole section. So -6 has a point at -1. Now I'll come back and do that in just a second. So -6 all the way, and shade it all the way till you get to the point that has an x value of 9. So it'd be this whole section right here. Okay, now I'm going to go back and I'm going to put in an open circle at -6 and then solid point where x value is 9. Okay, so my range, again, look at your lowest value. So my lowest value is here, which if I draw an arrow all the way over to the y value, we can see that that is at -10. So I'll start with that. And then the highest value is up here. Sorry, it's not a very straight line, but it's at +2. Okay, now just look at those points. At -10, we have a solid point, so that's going to be a hard bracket. And at +2, that's a solid point too, and so we're going to have a hard bracket there as well. If I write it in inequality notation, it's going to be the lowest value, -10, less than or equal to, again, because it's a solid point, y less than or equal to 2. Okay, in this next example, it says the graph has a range of all real numbers. So we're looking at the range. Again, that's from the bottom of it goes to -infinity, and the top of it goes to +infinity. It's not a function because it fails the vertical line test. So if we wanted to make it a function, we would need to restrict the range. What could we restrict the range to so that the graph would pass the vertical line test and be a function? Again, we're trying to restrict the range, not the domain anymore. We're restricting the range. Well, so what that would look like is we would basically just want it to be either the top part of my graph or the bottom part of my graph. So it could be either one. It could be this part of the graph, or it could be the bottom part of the graph down here. So we can do either one. So let's do both. For the yellow part of the graph, what we would want to do to restrict the range is the bottom of the graph would go to -infinity, and just remember, we always use parentheses for -infinity. And then the top part of the graph would be at 0. Now we can put a hard bracket at 0 because, again, we would just stop it at that point and it would still be a function. Now the other option is to do the top part of the graph. The top part of the graph would start at 0 and it would go all the way up to infinity. So that is a way that you can restrict the range, and then that way, if we're just looking at that part of the graph, so I can show you this really quick, if we're just looking at like the yellow part of the graph, okay, then it's like this whole thing disappears, okay? Well, if that disappears, then you can see that that yellow part is a function. And then the same thing would apply to the blue part. If the yellow part disappears, then just that blue part would be considered a function. Okay, this last problem is an extension problem, so it requires you to think a little bit. It says the graph represents the path of a football that Dak Prescott throws to Amari Cooper. The equation to model the path of the ball is given by h of d equals -0.04 d squared plus 1.56 d plus 5, where h is the height of the ball at any given horizontal distance d. The domain of the function is all real numbers, which is that double bar r, and the range of the function is y is less than or equal to 20. However, in context of the situation, what would be a reasonable domain, which is the horizontal distance the ball travels, and a reasonable range, which is the vertical distance the ball travels? Okay, so let's think about this in real world application. Okay, if you look at this graph, a part of the graph goes into the negative numbers. Okay, so if I'm looking at this here, I see that this section over here is negative x values, and I see that this graph over here is negative y values. Well, if we're looking at the y value, which is the h, if we're looking at the h as being height, we're not going to have a negative height. That doesn't make sense. And then the horizontal distance is d, and again, distance is not going to have a negative value either. So when we're restricting the domain to match this problem, we're really only going to be looking at the positive values. So let's go ahead and look and see what that is. Well, it looks like the 0 value for x looks like it's at approximately 1, 2, well, let's see. Sorry, these are going by 2, 4, 6, 8. They're going by 2, so it looks like it's going through right here, which is approximately 5. Now, we don't know if this is in feet or yards, but since we're talking about football, I'm going to guess that it's probably, the distance is probably yards. Now, the height might be in feet. We don't know, but again, we're not going to put the labels on that. So, if I'm looking at my domain, it's probably starting at that 5 feet, because of course he's going to start to throw the ball, you know, above the ground, right? He's not starting at 0. That wouldn't make sense. That would be like you're throwing the football from the ground. Well, he's starting at 5. Okay, so we're going to put that as our beginning value of, oh, I'm sorry, I'm thinking of range. Let me go back and change that. All right, so let's start over here. The domain is your x value. So starting at that 0, that's going to be the beginning part of my domain. Okay, now, what does it end at? Well, it looks like it's ending at approximately maybe 42. That's going to be where, obviously, if we're ending at that spot, Amari Cooper did not catch the ball and it hit the ground at 42 yards, let's say. Okay, so 0 is going to have a hard bracket because that is where he started. And then 42 is also going to have a hard bracket because that's where it hit the ground. Okay, now let's look at the range. Well, the range, the lowest value of the range is over here, which is at 0. Okay, so we're going to start the range at 0. And then the top of the range is at the very highest point. Well, the highest point up there is 20. And we have that in our range in the actual problem. Okay, so the highest point of the graph was at that 20 feet, yards, whatever the measurement is. Again, that's going to have a hard bracket because it did actually reach that point. So when you're looking at a real world example, obviously this equation is not only going to graph the part that you need to look at. So that's where the restrictions come into play. If I asked you, what is the maximum height that the football reached? Well, the maximum height is going to be up here, and it's going to be at that 20 feet. If I asked you, like, how far did he throw the ball? Well, that's obviously going to be your horizontal distance, which is 42 yards. Okay, so I hope this was helpful. Please make sure that you complete your assignment and ask me any questions that you need.